Factoring the greatest common factor. So this kind of starts off with some review. It says, recall distributing from the beginning of the year. So number one says, multiply the following polynomials by the monomials by distributing. So this is just a little bit of review from the beginning of the year. And the reason that this is here is because this idea of factoring relates to distributing. And I'll explain that a little bit more in a bit. But let's just review distributing. So remember, distributing, when you use the distributive property, you're really just multiplying. So I'm going to multiply this 5x to the second times everything that's in the parentheses. Okay, so the 5x to the second times 1x to the third would be 5x to the fifth. Remember, we add the exponents when we have similar bases and we're multiplying them. And then the 5x to the second times negative 2x. 5 times negative 2 would be negative 10. And then x to the second times x to the first would be x to the third. I'm going to do the ones in the left column here. So in this one, I'll distribute the negative 4x to the fourth. So negative 4x to the fourth times 1x to the second would be negative 4x to the sixth. And then negative 4x to the fourth times 3x would be negative 12x to the fifth. On E, 3xy squared multiplied by x to the fourth y would be 3. I would have x to the fifth and y to the third. So remember, I'm adding the exponents here. Distribute there. 3 times 2 is 6. X times x would be x to the second. X to y to the second times y to the third would be y to the fifth. So that's just a little bit of a review. When you're distributing, you're multiplying a monomial by a either a binomial, a trinomial, or you're just using the distributive property. So I'll let you do the 3 on the left. Now, the reason that I want to do a little bit of review there is because when we're factoring, this is a new term, it's the opposite of distributing. So we're trying to undo it. So like, for instance, on these examples here, what we're going to do is we're going to take like an expression that we built and we're going to go backwards. That's what factoring is. And this idea of distributing is actually really nice, as you can see in this tip, because you can distribute your answer to see if it matches the original problem, to see if you factored correctly. So here we go. Let's jump into it. So number 2, factor the following polynomials by finding its greatest common factor. Okay. So first, when we're working with this expression, I'm going to do A here, is let's look at the numbers. So we have 5 and 20. So the first thing is, what is the greatest common factor of 5 and 20? Well, you know, the only factors of 5 are 5 and 1. The factors of 20 are 1, 2 times 10. So 2 and 10 are factors. 4 times 5 are factors. So the greatest common factor would be 5. So we're going to be able to factor out a 5. So I'm going to write a 5 there. And then let's look at the variables. I have x to the fifth and x to the second. The greatest number of x's I can take out of both of those terms is 2, because x to the fifth has 5 x's in it. X to the second is just 2 x's, so I can take out 2 x's out of both of these terms. So I'm going to factor out an x to the second. So that's the greatest common factor of 5x to the fifth and 20x to the second. The greatest common factor is 5x to the second. So now it's kind of a little bit of a puzzle piece into what I put inside my parentheses. So if I need a 5x to the fifth, I know that this needs to be x to the third, because 5x to the second times x to the third would give me that 5x to the fifth. Put my subtraction symbol in there. And then we're working with the second term here. We have a 20x to the second. Well, 5 times what is 20? Well, that's 4. And then I don't even need to put an x on it, because 5x to the second times 4, I guess negative 4, would be that negative 20x to the second. So this is its factor. Now, I always encourage you to check your work by distributing. So if we were to distribute this, let me just, don't write this. You don't need to write this, but let me just rewrite what I got over here. If I were to distribute this, that would indeed be 5x to the fifth. And this would be negative 20x to the second, which is obviously our original expression. So we've factored it correctly. So you can always check your factorization by distributing. Let me do B. So I always like to start with the numbers. So I have 6 and 10. So I think, what is the greatest common factor of 6 and 10? Well, they're both even. So I know 2 goes into both of them as a factor. Factors of 6 are just 1 and 6, and 2 and 3. But 6 isn't a factor of 10. 3 isn't a factor of 10. So the greatest common factor of 6 and 10 is just 2. So I'm going to factor out a 2. And I have x to the fourth and x to the third. Well, x to the fourth is comprised of 4x's. X to the third is comprised of 3x's. So the maximum number of x's I can take out of both of those is only 3. So I'm going to take out a 2x to the third. So now I need to look at these kind of terms individually. What do I need to put in that first kind of blank there to create an equivalent expression? Well, I know it's going to have to be 3 as my coefficient because 2 times 3 is 6. And then to get to that x to the fourth, I just need an x to the first. That'll give me 6x to the fourth. And then for that second term within the parentheses, well, 2 times what gives me that 10 I need? Remember, now I'm looking at this term. That would be 5. And I don't even need to put an x on that because 2x to the third times 5 would be 10x to the third. Oops. So this is its full factorization using the greatest common factor. And again, you can distribute to check. And you might be able to do that in your head too. 2x to the third times 3x is 6x to the fourth. And 2x to the third times 5 is 10x to the third. Let me do some more. C is a little bit unique because it has a negative leading coefficient. And typically when you have a negative leading coefficient, we see that -3 out there, we're going to want to factor out a negative. So let's look at this. We got -3x to the fourth minus 12x to the second plus 15x. So what's the greatest common factor of all those? And the answer to that would be 3. 3 goes into 3, obviously. 3 goes into 4. 3 goes into 15. That's the greatest common factor. You can factor out a 3. And more specifically, since it's a -3, I'm going to factor out a -3. Now let's look at the variable, the x's. I have an x to the fourth, an x to the second, and just an x to the first. Well, since we have an x to the first, that's the maximum number of x's I can take out of each term. I can't take out like an x to the second or factor out an x to the second because I can't. There's not enough x's within this term. So I can only factor out an x to the first. Okay, I'm going to set up my parentheses. So now I'm thinking, okay, this term here, what would give me the -3x to the fourth? So -3x times what would give me -3x to the fourth? That would be x to the third. Just 1x to the third. Again, if I multiply -3x times x to the third, that would give me -3x to the fourth. Now let's look at the next term. -12x to the second. -3x times what would give me -12x to the second? Well, -3 times +4 would give me the -12. And just an x times the other x would give me x to the second. Let's look at the third term. -3 times what would give me +15? That would be a -5. -3 times -5 gives me +15. And I don't even need to put an x on that because -3x times -5 gives me +15x. And I'll just repeat this if you want to check your answer. And that's, again, why we started off this lesson with review, is by distributing. That would give you -3x to the fourth. this would give you negative 12x squared. And that would give you positive 15x, which is equivalent to the original expression, meaning we did it right. So that's how you can check your work. Okay. Let me show you one more D. So first I look at the numbers. I have a 2, a 7, and a 9. So I ask, what's the greatest common factor? Well, 2 only has factors of 1 and 2. 7 doesn't have has a factor of 1. Even 9 is a factor of 1, but they're odd numbers. They don't have a factor of 2. So on this, you can't factor out any number. Sure, you could factor out a 1, but that's pointless, right? So we can't factor out a number. There's not a greatest common factor with these, I guess, other than 1, but we're not going to factor out a 1. That's silly. So now we can just look at the variables. So I have an x to the 5th, the x to the 4th, and x to the 2nd. The greatest number of x's I can factor would just be 2 of them. So I'm going to factor out an x to the 2nd. So this first term is still going to have a 2 on it because I wasn't able to factor any sort of number out. I would need an x to the 3rd here. That would give me the 2x to the 5th. Let's look at this term. Still going to have my plus 7. If I factor out an x squared from an x to the 4th, I'll just have x to the 2nd. The final term, just be a 9. There wouldn't be an x attached to that at all. If I factor out an x to the 2nd from an x to the 2nd, there wouldn't be x's at all. Okay? So there's 4 examples. Now, I can't stress this enough, this statement. So just keep that in mind. Whether you do it in your head or you write it out, it doesn't matter. But always do that. Because this stuff up here, this distributing, you're probably pretty proficient at. Okay, so I'll let you do the rest of those. And then let me just show you a couple with 2 variables. So same thing. So let's do A here. I'm going to work with the numbers first. I have 8 and 12. So the greatest common factor of 8 and 12 would be 4. Now I'm going to look at the x variable. The maximum number of x's I can take out of both of those, I have an x to the 3rd and x to the 2nd, would be to factor out an x to the 2nd. And then the y variables would only be y to the 1st I could factor. Okay. So I would need it for this term, working with this term, first term there. If I factored out a 4, I would have a 2. If I factored out x squared, I would just have x to the 1st. And if I factored out a y from y to the 2nd, I would just have y to the 1st. And remember, distribute back in to check. If I factored a 4 from a 12 for the 2nd term, so now I'm working with the 2nd term, that would be 3. Whoops. Because 4 times 3 is 12. If I factored out an x squared from x squared, there wouldn't be any x's. And if I factored out a y from just a y to the 1st, there wouldn't be any y's. I don't need to put anything else on that term. And of course, always distribute to check. Let me try B. So I have a 4 and a 6. Greatest common factor of 4 and 6 is 2. The most number of x's I can take out is just one of them. And that, if we're looking here and here, right, the most number of x's I can take out is just 1. And then even with the y's, the most number of y's I can take out is just 1, showing from that 2nd term. So I'm going to factor out a 2xy. So if I factor a 2 from a 4, I'm going to need a 2 here. If I factor an x from an x, there's not going to be an x term in there at all. If I factor a y to the 1st from a y to the 4th, I'm going to have y to the 3rd. I'm going to need a 3 here. Factor out an x from an x squared. I'll just have a singular x. And I'm not going to have a y. Because if I factor a y from a y, there won't be a y in there. And remember, distribute to check. 2xy times, 2y to the third would give you that 4xy to the fourth. So like that, remember, always like distribute to check. I feel like I'm redundant. I keep saying that. All right. C doesn't have any numbers to factor out, so I'm really just looking at the variables. The maximum number of x's I can take out is just 1, indicated here. And the maximum number of y's I can take out of both terms is 2, indicated here. So I'm going to factor out a x y squared. So in this first term here, if I factor an x from an x to the third, I'll just have an x to the second. Factoring a y squared from a y squared, I wouldn't have any y's there. On the second term, I won't have any x's because I'm factoring x from an x. There won't be any x's. And if I factor a y squared from y to the fifth, it'll be y to the third. One more. Greatest common factor of 2 and 10 would just be 2. I should be able to factor an x to the first out of both of those terms, and then a y to the second out of both of those terms. So on this first term, I'm going to need if I factor out a 2 from a 2, it'll just be a 1, and then I'll have an x, and then a y to the third. And then the second term, it should be a 5. 2 times 5 is 10. No x's, and then no y's actually either. Now, let me just, you can turn off the video now if you want to, but let me just show you one last time. Remember, you can always check your answer. 2xy squared times xy to the third plus 5, distribute. That would be 2x to the second, y to the second times y to the third would be y to the fifth. And then 2xy squared times 5 would be 10xy squared. This is, in fact, equivalent to our original expression. It's the same thing, right? So that means we did it correctly. All right, so I'll let you try all the other ones. I know this can be tough, but give it your best shot.